Good evening, everybody out there. I hope you're having a great night. And today we're going to have a short little lecture continuing on chapter 6. And we are going to be talking about why do we need to do any conversions. So we're going to be showing you how to do some conversions, but why do we even need to do them? Well, the first thing is we need to be able to compare things. If you're taking a look at, we've been talking a lot about the measuring unit of a dozen. If you take a dozen pop bottles, a dozen newspapers, a dozen potatoes, you can take a look at the amount of space that they take up. You can take a look at the amount of mass that they have. But what you need to do is you need to make sure that you have 12 of each substance before you're going to sit and compare. So the same thing here. We want to be able to compare not potatoes or pop cans or whatever else I just said, but we want to be able to compare the reactants and the products. So we want to be able to take our compounds and we want to be able to compare compounds. And the easiest way to compare our compounds is if you take a look, if we have this reaction A plus B and yields C plus D, we want to be able to compare these things. And the best way to compare them is by doing conversions. So we're going to get started. How are we going to do these conversions? Well, the first thing is, I know I keep talking about this, but you need to get out your mole maps. So hopefully you have this gold sheet in front of you. If you don't, pause me for a second so I stop talking and get out your mole map. We're going to continually talking about this mole map, and we are going to be today converting from moles over here to grams over here and back and forth. So you're going to want your mole map in front of you as I'm talking so that you can understand the conversions that I'm making. Okay, so the first thing is we want to go from moles to grams. So in order to do that, we are going to take the number of moles and we're going to multiply it by its molar mass. So if I was doing a mole map on this, you would be taking a look at your mole map, and I am going from moles to grams. So here's an example that we have here. What is the mass of 6 moles of calcium chlorate? So what we're saying here, remember, you think of a mole, 6.02 times 10 to the 23rd, or think of it as a dozen. So how much does 6 dozen of calcium chloride weigh? Or in this case, moles. So the first thing we need to do is we need to take a look and write the formula for calcium chlorate. So hopefully you're already ahead of me on that. So you have Ca plus 2, and you have chlorate that has ClO3 with a -1 charge. And so if I balance this out, I have calcium chlorate. I need 1 calcium for every 2 chlorates. This is a 3 right here. Okay, so the first thing I'm going to do in all of these cases is when it's talking about mass, I probably should be thinking molar mass. So the first thing I'm going to do is calculate my molar mass. And I'm going to say that I have 1 calcium. And hopefully you're taking a look at that we have 2 chlorines and 6 oxygen. So I have 1 calcium, I have 2 chlorine, and I have 6 oxygen. So I'm grabbing my lovely periodic chart, one of the gifts that Miss Benson has given you, and I'm rounding each one of these masses to the 10th place. So calcium is 40.1, chlorine is 2 times 35, 0.5, and we know oxygen by now is 6 times 16. And I do the math and I'm going to add all of these up, and my molar mass is always going to be to the 10th place. So this is going to be 207.1 grams per mole. As we're going along, make sure that you are always verifying with your own calculator that you are getting and keeping me honest and getting the same answers. Okay, so next what we're doing is we are ready now to go from moles to grams. And if you take a look at your mole map, and let me grab that for a second. If you take a look at your mole map, you can see that, I should move that the other way. If I'm going from moles to grams, I am going to be multiplying by my molar mass to get here. So let's go ahead and do that. So always start with what you're given. We are given 6 moles, 6.00. Keep in mind that that is 3 significant figures. So I have 6 moles of calcium chlorate. I'm going to multiply by its molar mass that I just figured out, 207.1 grams per mole. Make sure you're writing down all your units so you can see how they cancel out. And if I take a look at how these do cancel out, I have moles on top and I have moles on bottom. I'm left with grams, which when I read my question, it says, what is the mass? And that is going to be what I am looking for. So I have done that correctly. I have 3 significant figures here. I have 4 significant figures here. When I multiply this out, I hope that you are looking at 1,242.6 grams. And to round that to 3 significant figures, I should get 1,240 grams of my calcium chlorate. Okay, and that's it. That's all you have to do. So you're going to do the same thing in the next problem. So I have this example that I have done for you. And then you have another example up here that's kind of hidden by my record button up here. So what is the mass of 5.08 moles of calcium nitrate? So go ahead and find its formula, find its molar mass, and then do the conversion. When you do that, go ahead and try this. You should get 834 grams. So go ahead and pause before you go any further and see if you can calculate this one out. Okay, now once you got that and you're successfully doing in that direction, we are going to go in the opposite direction. So now we're going to go converting grams to moles. So you're going to divide the number of grams by the molar mass. So in this one, it says how many moles are contained in 200 grams of carbon dioxide. All right, so I'm given grams, and where do I want to go? I want to go to moles. So you're going to go ahead and take a look at your mole map, and your mole map is going to show you that if I am given grams and I'm going to go to moles, this time I'm going to divide by my molar mass to get to my answer. Okay, so here's my example. Same thing, it says how many moles are contained in 200 grams of carbon dioxide. So I need my formula. Carbon dioxide is a molecular naming system, so I don't look up any charges. So carbon dioxide is simply CO2. I'm going to do my atom inventory. I have 1 carbon, 2 oxygen, and carbon has a molar mass of 12.0. And I have 2 oxygen at 16.0. Add that up. And I am going to see that my molar mass is 44.0 grams per mole. Okay, so now I have all the pieces of the things that I need. So I'm going to go ahead and solve my equation here. So if I take a look, I'm going from grams to moles. So write down what you were given. You are given 200 grams. 200 grams. Significant figure of 3 because of that decimal there, divided by my molar mass is 44.0 grams per mole. And I divide that out. You can see that the grams are going to cancel out, and I am left with moles. So this is my unit, and that's what I am looking for, so I have done it in the right manner. I have 3 significant figures, so my answer should be 4.55 moles of carbon dioxide. Okay, so there's my answer there. So you have an example here to do on your own, and go ahead and use your mole map again. Find the formula of tin 2 fluoride, find its molar mass, and divide it out. When you do that, you should get 2.13 moles. Okay, that's it for tonight. Nice, short, and sweet. Hopefully you got those 2 problems. And I will see you soon. Have a wonderful weekend. Get some rest. Take some time for yourself. It's been a tough one this week. I am thinking of every single one of you. Have a wonderful night.